Great. Now the blue channel of our material mask is ambient occlusion, and we're not going to tackle that until the end. So let's move on to our paint. The first thing I'm going to do is I'm going to choose two nice contrasting colors. So I'll choose maybe a deep blue, and then I'll choose a bright orange. I'm going to move all these out of the way. So if I hold down Alt and left click and drag, it'll drag out a box, and I can move them all out of the way. I just know I'm going to need a bit of space for this. Okay, so here's how the paint mask is going to work. First is that we are going to blend between our accent paint and our main paint based off of the red channel, which was our accent paint mask. So if I'm going to need another lerp for this. I'll plug the red channel of paint mask into lerp, and then where it's white, the B value, that'll be our accent paint. And then where it's black would be where our main paint belonged. So you see we get this mixture of the two. Then what I need to do is I need to blend between the resulting paint and where it's supposed to be applied onto our base color map. So for that, I'll need another lerp node, and I'll use the main paint mask. Now the reason why I'm using the main paint mask here is because both the accent paint and the main paint are going to be blocked by things like the dirt and the scratches. So what's happening is I'm going to combine both paint colors and then mask them out as a group with my main paint mask. Now, because the white values on our main paint mask indicate where paint should be applied, I'll plug the resulting paint combination into B and then the base color into A. And then I will drag the entire result of this into base color. Now as you see, we now have our paint. It's being blocked out by our dirt. It has the roughness applied. Looking pretty good. So let's mix this up a little bit. Let's tackle, actually first, let's tackle a slightly simpler operation first. Let's apply the ambient occlusion. So the way we're going to do that is we're going to use a multiply node. Now here's why. Remember, the ambient occlusion map here in 3D Coat is actually just it's a black and white texture map that has its blending mode set to multiply. That allows it to darken everything. Now here's how multiplying works. If I go here, so here I have two layers. I have a gradient and I have a color. Now for a black and white gradient, programs like Photoshop and 3D Coat may tell you that these colors are on a range from 0 to 255 if you're using an 8-bit color setup, but that's actually not true. They're really values between 0 and 1, with black being 0, 1 being white, and the gray values being some decimal in between. So what's happening when you are changing the blend modes here to say something like multiply is you are multiplying those 0 to 1 values by the color values of the layer beneath it. So what happens when you multiply something by 1? That's an identity property. You get the underlying color. What happens when you multiply something by 0? You get 0. That's why the multiply mode makes everything look darker, because if you multiply something by a value less than 1, it decreases the underlying value. So our shader is going to work in much the same way. I'll bring in a multiplying node by just holding down the M key. And what I'm going to do is I'm going to bring in the result of our lerp into B, and I'll bring in the blue channel from our material mask into A. Now you'll see that made our resulting texture a lot darker, and I'll drag the result of that into base color. And watch how our, watch how our object changes. As you see, it has a lot more depth now. That's why I chose to include this, but that's why it needed to be added on later. If we had baked the ambient occlusion into our base color, it would have been covered up by this lerp node. Alright, now let's tackle what will probably be the trickiest part of this entire shader, which is the hue adjustment. So, what we need to do here is we need to convert these colors from red, green, blue values into hue, saturation, and value values. That was not a very well worded sentence. Now let me explain how HSV colors work. So here we have 3D Code's default color picker. Now colors can be built in one of two ways. You can use either red, green, and blue RGB values, or you can use hue, saturation, and lightness, or HSL values, or HSV, depending on what program you're using. So the way that HSL works is that we have the color is defined by the hue, which in this case would be going left to right. Saturation, which in this case would be going from bottom to top. As we go up, it becomes more saturated. And then value, which would be this one, how bright or how dark the color is. Now all of these values are between 0 and 1. Here on the left is 0 hue and 1 saturation with 0.5 lightness. And hue increases all the way up to 1, which is just short of where it began. So it's actually cyclical in this way. So all these values are 0 to 1. This is 0 lightness, this is 1 lightness with maximum saturation. ShaderForge includes an interesting utility that allows you to make use of this color scheme. So if I hold down R, I can convert a color from RGB to HSV. So I will convert it. Now the color may change, but don't worry, we haven't actually lost any of that data because we're going to be converting this back into RGB later. Now I'm going to need 2 of these. Because we have 2 colors. And I'm going to move these back a little bit. Now what I'm going to need next is a special type of node known as a Remap node. Now remapping is pretty interesting. It's very powerful, but it's a little confusing. Here's how it works. What a remap node allows you to do is basically scale the black and white values of an input. So the default for a remap simple node here is to go from 0 to 1 to -1 to 1. What that means, one way you can think about it is, think of it as 2 number lines. We have 0 to 1 and then -1 to 1. So what's happening here is that we're going to take an input, let's say a black to white gradient. And what's going to happen is that it'll take a look at these 2 number lines and it's going to draw comparisons between them. And I just realized I am not in color. So if our input value in this case was 0.5, it's going to get remapped to 0 because that's halfway on the new timeline. If it was 0.25, it's going to get remapped to negative 0.5. If it was 1, it's just going to get remapped back to 1. But that's a remap node. And the reason why that's important is that we need to scale our noise channel in our paint mask.